All right, guess what we're doing tomorrow? 7374. So that was what? Pythagorean theorem and special right triangles. All right, so 1, 2, and 3, I give you 3 right triangles, and I ask you to, I give you 2 sides, and you just got to find the other side. That's all it is. So 1 to 3 are right triangles. And I give you 2 sides, you just got to find the other side. One of the triangles I give you is a, what do you call it? Ordered, no, what do you call it? Something triple. What do you call that thing? What was the triple thing called? Yeah, what do we call that? Pythagorean triple? Is that what we call it? Nah, it seems like you called it something else. Is that what I called it? I can't even remember. Was it a Pythagorean triple? For some reason, that just, yeah, it is. It's called a Pythagorean triple. I don't know. It just sounded weird when I said it. It just didn't seem right. But that's what it is. All right, so what if I told you that that was 5 and that was 13, and I ask you for that? Yeah, that's right. You can just look at it and write down the answer, all right? Because if you know your Pythagorean triples, you can just look at it, figure out what it is. Would you agree? What if you didn't remember your Pythagorean triples? Yeah, you could still just do Pythagorean theorem on it, couldn't you? You want to do that just for practice? Okay. So you said it came out to 12, correct? Let's see if it really does. All right, remember, technically we don't know that yet. So what would we do? I'd go x squared plus what? 5 squared, and that needs to equal 13 squared. The important thing about the Pythagorean theorem is this is always the what? Hypotenuse, thank you. It's the hypotenuse. It is the longest side, that's true, but more specifically, it's the hypotenuse, okay? So let's do it. So that's x squared plus 25 equals, that's 169. Subtract 25 from both sides. Oops, 25 from both sides. X squared is, what's that, 144? Then how do I get that x by itself when it's an x squared? Square root. Okay. So you square root. So what's this, square root of 144? You should be able to do that in your head. It's 12. There you go. But knowing your Pythagorean triples, that would have saved you from doing all of that work. Do you agree? Yeah. No, just one of them. Just one of them is going to be a Pythagorean triple. All right, then I'll give you another one. This is Pythagorean theorem. It's not a Pythagorean triple, though. I can't hear you. Oh, what are they? 3, 4, 5 is the smallest size. 5, 12, 13. 8, 15, 17. 8, 15, 17. And then 7, 24, 25. Well, I'm sure there's more, but that's all we got to worry about. All right, so 3, 4, 5, 5, 12, 13. Tell you what, while we're on the subject of Pythagorean triples, what if I said this? What if I said that this was 6 and this was 10? What is x? I don't think we've discussed that one yet. Why 8? You don't know? It's just a guess? She already said it, and I said it was right. Yeah, it's 8. But why? Why is it 8? Yeah, this is a 3, 4, 5 triangle. Like, wait a minute. It doesn't have a 3, a 4, or a 5 in it. How in the world is that a 3, 4, 5 triangle? It's just double it. Exactly right. This is double 3, right? This is doubled 5. So this is going to be double 4, which is 8. So that technically is also a Pythagorean triple, isn't it? Right? But it reduces to what? 3, 4, 5. So I don't have to have a million of them, because I would. I would have really more than a million. I would have, what's the word? An infinite number, right, of 3, 4, 5 triangles, right? Because you can just keep on multiplying 3 by whatever, by 2, by 3, by 4, by 5, by 6, okay, whatever. So look for that sometimes, okay? Look for that. Because what I would do is look and say, oh, 6 and 10. Well, 2 divides into both of these, right? 2 divides into this 3 times. 2 goes into this 5 times. And then there you go. Oh, there's a 3. That's probably 4. That's probably 5. But how do we go from 3 to 6, 5 to 10, 4 to what? 8. Correct? All right, so you can do that as well. Go ahead. No. It's just, you look at it. I mean, let's do another one. What if that's a 21, right? And that's a 28. What's that? Yeah, because look at 21 and 28. What divides evenly into both of those? 7. 7 times 3, 7 times 4. What's this? 7 times 5, which is 35. Make sense? Well, if it's a Pythagorean triple, it'll work, right? So, for instance, you could have look at this. What if you had this? You see anything in common? Yeah, 3's in common. So 3 goes into this what? 5 times. 3 goes into this what? 13 times. So 5, 12, 13. But it's 5 times 3 and 13 times 3. So this would be 12 times 3, which is 36. Make sense? Everybody good? All right. Now, you could have also, if you didn't realize, right, that and that were true, you could always just do Pythagorean theorem, okay, which is what? X squared plus 15 squared equals 39 squared. Now, a lot of this you probably can't do in your head. Would you agree? All right, so you pull out the calculator and you could go from there. What's that? What'd you say? Yeah, but do you really want to do? I just watched a video today. Girls, please. Just watch a video today. They're trying to show you like they call it an easy trick to take a 2-digit number and square it. I don't even know if I remember how to do it. But they so if it's 39 squared, let's see if I can do this. 39 squared, they say you're going to get 3 numbers. All right, so if you take that first one and square it, you get a 9. You take this one and square it, you get an 81. And then, right, I agree. When I watch the video, they're like, "Oh, everybody can do this. You can square 2-digit numbers in seconds, and you just do it in your head." But I was like, you know what? After going through all this mess, you might as well just go 39 times 39 and do the multiplication, because that would be just as easy, right, as doing all this mess. So it's like you square this one, and then I don't know if the 8 goes here, and then you multiply these two together, multiply by 2, and then stick it in the middle. And then sometimes if this is not a single digit number, then you got to add it to this. Oh, it was clickbait. You know what I mean? There's like, oh, wow, I want to know how to multiply or I want to know how to square 2-digit numbers very quickly and easily in my head. But it would be just as easy doing this than it would that thing right there. Now, there are some numbers that work out kind of nice, but I don't know. You can look it up. It's online. It just popped up in my feed, and I looked at it, and I was like, okay. I was all excited. I was like, oh, I got this new trick I'm going to do. And then they went on and on and on. I'm like, what? I was like, there's more steps to do the trick, right, to do the little thing than there is to just multiply those two things together. Anyway. All right, so the first three, are all just straight up Pythagorean theorem, right? You got to find missing sides and stuff. There we go. What if you did a Pythagorean theorem? I don't know. I'm just trying to think of a number that I could simplify. What if it came out to like the square root of 80? So you did the whole Pythagorean theorem thing, and you got your answer to be the square root of 80. Yeah, this is any problem. All right, any problem. 4 square root of 5? Okay, on your calculator? Yeah, well, that doesn't mean you did it. Right, Ian? Right. So look. If I had the square root of 80, how could you break this thing down? You could break it down a couple ways. Now, there is one way that you could do it to make it a lot shorter, but I doubt that you know that multiplication. Like 16 times 5 is 80, all right? But is that a number that just pops in your head real quick? No, probably not. But it works though, watch. 16 times 5, all right? What's the square root of 16? It's 4, and then what do you do with that 5? Keep it under the square root. Okay, 20 times 4 would work. Okay. Here's what I would do if I didn't realize. Now, I did know that 16 times 5 was 80, so I'd probably use that way. But let's say I didn't. And I'm like, okay, what times what is 80? Well, you're right. 2 times 40, and you can use that. Or 4 times 20, right? You can use that. Or I'm going to kind of split it down the middle. 8 times 10. Would you agree? Now, watch very carefully. I don't think I've really shown you this before, but it's a nice way to do it with a number that you can't really think in your head what times what, and then one of those numbers you can take the square root of. So what I'm going to do is break them all down, okay? Break down 8. What's that? 4 times 2. That's 8. Break down 10. That's 2 times 5. Would you agree? Now, you could have broken the 4 down into another 2 and a 2, but you already know. So watch this. You know the square root of 4, which is what? 2. Correct? Look at this. What is that right there? That's a 4. So what's the square root of this 4 right here? That's also a 2. Agreed? So the square root of 4 is this 2. This 4 right here, the square root of that 4 is that 2. What do we have left over? Square root of 5. 2 times 2 is 4, square root of 5. So that was an okay way to do it. It would be really nice if you knew it was 16 times 5, but they don't all come out quite that easy. Make sense? So that's how you would simplify something like that. On this quiz, I want you to simplify all the radicals. Well, I want you to get this answer. If you have a calculator that can give you that answer, then more power to you. Not all calculators can do that. All right, so you need to know how to get from here to here. So this is simplified. You got it? You can do this if you want. You can go through that right there, or you could have done this. Almost hate to say you can use a calculator, but I'll let you use a calculator. And if you have a calculator that can do that, but again, not every calculator can change it from this form to this form. Now, every calculator can change it to a decimal, but is that what I want? No, I want exact, simplified answers. Understand? All right. I don't say it on the quiz, but I'm telling you right now. Actually, on a couple problems I do. I say find the exact lengths in the triangle on a couple of these problems. So when I say find the exact lengths, that's what I'm talking about. I'm talking about not putting into a calculator and getting a decimal answer. none of these, let me look. Yeah, none of these are going to be decimal answers. You with me? All right. So now let's do 4 and 5. 4 and 5, I'm going to give you 3 sides of a triangle, and you tell me, is it acute, obtuse, or right triangle? Remember that? So this is 4 and 5. So, I don't know. Give me some sides. Let's just make up some stuff. 5, 7, and what does this need to be? Remember, these two have to add up to be what? 15. Bigger than this. No, you can't have a 15. These have to be bigger than this. So this is 12, so it has to be less than 12. So let's say 10, all right? Everybody with me? So if I have a triangle that has 5, 7, and 10, what kind of triangle is it? I think in the previous quiz, didn't we have one where he says, is it a triangle? Like, do these, or maybe it was another chapter. We said, do these 3 sides add up to be a triangle or make up a triangle, right? And you had to add them up. And if this was bigger than this, then yes, you can make a triangle. If it was not bigger than this, it was not a triangle. But this goes a step further, okay? Yes, it's a triangle because 5 plus 7 is 12 and 12 is bigger than 10. So yes, it's a triangle, but specifically what type of triangle is it? Acute, obtuse, or right? How do we do it? First of all, I take the c, remember this? I take the c squared and I compare it to the a squared plus b squared. If it's equal, it's a what kind of a triangle? If it's equal, it's not obtuse. What did we just finish doing? Right triangles. The Pythagorean theorem is c squared equals a squared plus b squared. That's a right triangle. What if c squared was less than? Then it would be acute. What if it was greater than? Then it would be obtuse. Okay? So that's what we're going to do right here. So don't start with the 5 and the 7. Okay, I recommend that you not do that. Start with the c. All right? Put it right here. So what do we got? We got 10 squared. And then we got 5 squared plus 7 squared. So let's do the math. I'll put a question mark right there because I don't know right now until I do the math if this side is equal, less than, or greater than. 10 squared is easy. That's 100. This is what? 25 plus 49. What's that? 60, 74. Is that right? What is 100 compared to 74? It's greater than. So what kind of a triangle is this? It's an obtuse triangle. And that's 4 and 5. Good? Good. Alrighty. Now, that was all Pythagorean theorem stuff. Now, we're going to do the special triangle things. All right, so let me try to draw a 45. And let me do this. What do I want to do? Make this 90 maybe? Should have just drawn it by hand. Would have been easier. Nope, it's not that. Anyway, forget that then. Let's just do this. I'm just going to try to make these two equal to each other. We'll just say they are. All right, here we go. It's the next one. This is 4 and 5. So what do you think comes next? Sorry to be so snippy with you, but you could have figured that out, couldn't you? So this is number 6. Well, I got 145, 45, and then I got a 30, 60, 90. So I got a 6 and a what? And a 7. So this is 45, 45. These are in degrees. All right, and I give you one of the sides. I don't know. Give me a length. 12. All right, so that's 12. We'll call this A. We'll call this C. And on number 6, this is not 6 and 7. This is just number 6. I got to solve for A and C. A should be super easy. C shouldn't be that much more difficult. But A is definitely the easiest out of this. Right? So what is it? What is it? 12? Was that a question or you're telling me? Why is it 12? Same sides, right? These two sides are equal to each other, correct? Because this is 45, the opposite sides are equal. So these two sides are equal. So if that's 12, what's A? That's also 12. What about C? We had a little thing that we learned just the other day. Let's write it down. Hypotenuse is equal to what? Square root of 2 times the leg. All right, this is how we wrote it every single time. All right, hypotenuse is the square root of 2 times one of the legs. Well, check it out. Do I know one of the legs? Yeah, I know both of them. It's 12. So how do I find the hypotenuse? Just multiply it by what? Well, multiply the leg by square root of 2. So I'm going to go 12 square root of 2. See, it wasn't much more difficult. It was just a little tiny bit extra with that square root of 2. Everybody good? I could go the other way, though, couldn't I? What if... Give me a number for this. Oh, let's do it. Let's not do 144. Let's do, like 20. That's good. Let's do 20. Okay? And I want to solve for A and B. Now, you know they're the same. So if I find one, the other one's exactly the same, right? All right. So that helps a little bit. But how in the world do I find one of the legs? Well, let's use this again. What do they tell us now? They tell us the hypotenuse is 20, don't they? So that equals what? The square root of 2 times one of the legs. Which leg do you want to find, A or B? All right, let's find A. All right, so we're using this little formula right here. We just stuck the numbers in, and now we solve for A. How do I solve for A? Divide by square root of 2. Divide this by square root of 2. Do we leave it like that? No. Remember what we do? Why don't we leave it like that is the question, really. Square root in the bottom. That's right. We don't want to square root on the bottom. It's not simplified that way. So what do? Put it to what? No. Come on, we've done this. Multiply it by what? Itself, which is square root of 2. Okay. Do we just do that? Just multiply the bottom by square root of 2? What else do we do? Yeah. Why? Because it equals what? 1. That's right. So all we're doing is multiplying by a 1. Does that change the value of it at all? No, not at all. All right, so I'm allowed to do that, right? Because all I'm doing is multiplying by 1. But it does change the way our numbers look, though. So what's the bottom going to be? Square root of 2 times square root of 2. It's just a 2. What's the top going to be? Yep, 20 square root of 2. Do we leave it like that, and that's our answer? Now we can simplify a little bit more. What do? 2 and 20. You see that? So 2 goes into 2 once. 2 goes into 20 10 times. So now, what's our final simplified exact answer? It's 10 square root of 2. So that's what A is equal to. So A is 10 square root of 2. What's B without any work now? It's 10 square root of 2. That's right. So there's my A, there's my B. That's about as complicated as these could get. I could do this. Now, you may think, oh my word, this one's really hard now. What if I said this was the square root of 17? Actually, let's make it a little easier. What if I said this was, I'll just make it square root of 14, okay? So let's say I said this was the square root of 14. Find A and B. You're like, oh my goodness, square root, that's going to make it really hard, is it? Well, watch. What do? Hypotenuse is what? Square root of 14 equals the square root of 2 times one of the legs. Divide by square root of 2. Divide by square root of 2. Look what we get. A equals, what can we do here? Square root of 14 over square root of 2 is the same thing as putting them under one big square root. Everybody see that? We're allowed to do that. And so 14 over 2 is what? So it's just the square root of 7. So A is the square root of 7. Ooh. There we go. And B is the same thing, square root of 7. Make sense? So really, having a square root there, did it really make it that difficult? Not really. It actually made it easier than if it was a whole number there. Would you agree? Yeah, absolutely. We good? Okay. All right. So that's 6. 7 is what kind of a triangle? 30, 60, 90. That's right. So now the two sides are not equal to each other on a 30, 60, 90. But there is a relationship, though, between all three sides. Do you remember that relationship? Let's go A, B, and C. All right. What's the relationship? Remember? They all relate to the what? No. The short side. They all relate to the short side. So I'll write it as hypotenuse. I was going to write it as A, B, and C, but I changed my mind. So the hypotenuse is equal to what of the short side? This is the easier one. It's double. It's 2 times. Okay, so the hypotenuse is twice as big as A. Got it? Now, what's the other side? This is the hypotenuse. That's a short side. What do I call this one? The long side. Okay, so the long side is equal to something times the short side. Square root of 3. Good. Right? This is something you got to memorize. Sounds like some of you do have it memorized and some of you don't. You got to have it memorized for tomorrow to know what you're doing here. Everybody good? All right, let's put some numbers in here. I'll make it this one right here. That we'll do a couple versions of this, okay? But the first version I'm going to do is like the easiest version. All right, so let me give you the short side. Give me just a simple number for the short side. 5. Okay. So let's make this 5, and let's find B and C. B and C. What do you think actually, they're both pretty easy since I gave you the short side, to tell you the truth. Let's do B first. What would B be? Short side, long side. Actually, yeah, either way, it doesn't make any difference. This is the long side, so the long side is what? Square root of 3 times the short side. So how do I write the square root of 3 times the short side? 5 square root of 3. Okay? See, this times square root of 3 is this. Everybody got it? How do I find the hypotenuse if I know the short side? You double it. That's right. If I know the short side, I just double it to find the hypotenuse. So what is that? It's 10. That's right. There you go. I'm sorry. I did it the wrong way around, didn't I? Let's change it. C and B. There we go. Yeah, so B is 5 square root of 3, and C is what? 10. Why? Because it's double the short side. Why is this 5 square root of 3? Because it's the short side times the square root of 3. So that's about as easy as I can make a 30, 60, 90. Technically, I should have done this, but I did say it was 30, 60, 90, didn't I? But I should have written it down. Let's do another version of this. I don't know. What if I told you that this is just about as easy as the other one was. Let's say that was 12. All right? And I want to find the other two sides, the A and B. Yeah, short side. That's what I would do right off the bat. Okay, since I know the hypotenuse, short side would be half of the hypotenuse, correct? So that would be 6. Now, once you know the short side, the long side's super easy. What's that? 6 square root of 3. There you go. There's your missing sides. It's kind of nice, isn't it? Yeah. All right. What's the most difficult part of doing 30, 60, 90? When they tell you the long side. Give me a number for the long side. Anything. What is it? 30? Okay. Make this 30. All right, if this is the long side, what do we have to do? Can we go directly to the hypotenuse? No, because there's nothing in here that goes directly from the long side to the hypotenuse, does it? But we can find the short side. So let's use this part right here. Everybody see that? So let's plug stuff in. Do we know the long side? Yes, 30 equals what? Square root of 3 times the short side. We'll call that A. We'll call that B. Is that right? So square root of 3 times what? A. So I want to find A. So how do I find A? We've done this already before, except we use square root of 2 instead of square root of 3. So what is it? Over what? Square root of 3 over square root of 3. Little problem. What's the problem? Can't write that as our answer. What's the problem with that? Got a square root on the bottom. So what do we do with that? Multiply it, top and bottom, because we're just multiplying by 1, right? So what do we get? Let's do the bottom first. Square root of 3 times square root of 3. Is it square root of 3? No. What's the square root of 3 times the square root of 3? It's the square root of 3 squared. What's the square root of 3 squared? It's just a 3, right? We've talked about this a lot, haven't we? Remember we did this thing where I said I don't know, square root of 17 times the square root of 17. Without doing any math, what is that? 17. Square root of 157 times the square root of 157. What's that? It's 157. What's the square root of 3 times the square root of 3? It's just 3. It's a whole number 3. Do not write square root of 3. It's not what it's equal to. It's equal to the whole number 3. What about the top? What do we do with that? I'm going to write 30 square root of 3. Are we finished simplifying this just yet? Not quite. One little thing to do. 3 divides into 30 10 times. So what do we get? 10 square root of 3. What did I just find? Found A, didn't I? The short side. So this is 10 square root of 3. That was the hardest way, okay? That was the hardest thing to find. When they give you the long side, the hardest thing to do is to find the short side. It's not that difficult to do. You just do a little division, simplify your square roots, right? And then you should be good. Now, once you find the short side, the hypotenuse is actually pretty easy. So what do we do to the short side to find the hypotenuse? You double it. That's right. So how do I double 10 square root of 3? It's 20 square root of 3. Exactly right. And there you go. So there's your hypotenuse, and there's your other missing side. That's if they give you the long side, okay? Again, the other are pretty easy, especially when they give you the short side. If they give you the short side, then the other two are pretty simple. Agreed? All right. That's it. Number 10. Oh, 8 and 9 are a couple other of these, except I'll tell you the difference. 6 and 7, I have pictures for both of them. The only difference between 6 and 7 is kind of like you're doing 4 of these. So you're doing 2 45, 45, 90s, and you're doing 2 30, 60, 90s, okay? The only thing different is on 6 and 7, I actually put the value on the triangle itself, okay? 8 and 9, I say, I'll make this like ABC, and I'll say if AB is square root of 7, find like AC and BC. I do draw the triangle. Yeah, I do draw the triangle, okay? But this is how I write it. So I don't write anything on the triangle except for the letters A, B, and C. You with me on that? It's the only thing different. Slight, subtle difference, no big deal. All right, so number 10 is a surprise question. Surprise. All right. It's like not a geometry problem. Everybody will get it right. Everybody get it right. Now, don't stress over this, okay? Everybody, no matter what you write down, as long as you write something. If you leave it blank, you'll get it wrong. If you just write something, then you'll get it right. But I think when I made up this quiz, when I first made up the quiz, I covered everything I could, and there wasn't anything where I could just put like one problem on there. And I didn't want like 3 30 60 90s and only have 2 45 45 90s. I'm like, oh, what do I do? I'm like, just give it to them. All right. But there is a question, though. It is a question. It's a silly question, but it's a question. Is it a quote? I don't even remember what I say, so it's probably not. Okay. Everybody okay with that now? All right. You want to use the rest of the time to go over those questions you had? Okay.